For this problem, example 2 from 3.1, we're going to analyze reasonable domains and ranges. So we've gone over example 1 and example 3. So we've talked about domain and range. Domain is the x values, range is the y values. Now there's functions all around us in your everyday world, in your parents' everyday world, and we need to come up with reasonable domains and ranges. Numbers that make sense for the given situation. So in the first part it says, a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So imagine at Fortson, the swimming pool, you put a hose in it to fill it with water. And that pool gets filled at 10 gallons per minute. So you want to think about what x's make sense and what y's make sense. In the second situation, completely different. It says a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So 2 different situations, but still, let's think about this. Now, the 2 things that we're talking about here are gallons and minutes. So I'm going to let you in on a little secret. Time is going to be our x. So time will be our x. Gallons will then be our y value. So think about time. Can you have negative time? Can you have fractions? Can you have decimals? Can it be a quarter of a minute, a quarter of an hour? Yes, you can. You can't have negative time. It's not negative 12 o'clock. It wasn't negative 5 minutes. But you can have positive numbers. The gallons, think about, can you have 2.3 gallons? Can you have a half a gallon? What is the maximum amount of gallons that the swimming pool holds? So those are all ideas that you need to put into a sentence to explain what the appropriate domain and range is. Same thing with the table. If you're at this restaurant, you can only order 4 at a time. You have tables that only can have 4 chairs. So you're going to want to do multiples of 4. Can you have a half a table? Can you have a quarter of a table? No, that doesn't make sense. You want to have whole numbers, positive numbers for the amount of tables and for the amount of chairs. So let's see what a sentence would look like. So for the first one, it says a reasonable domain is from 0 minutes to the time it takes to fill up the pool. So we don't know how far that is yet. We're not going to figure it out. So you just want to write a general sentence like that. And then a reasonable range is from 0 to 10,000 gallons. You can't go over 10,000 because then it would overflow, and we don't want that. Now think of the restaurant situation. A reasonable domain is from 0 tables to the number of tables needed. So once again, this is a very vague situation. We're not doing it exactly. So it depends on how many tables. And then a reasonable range is the multiples of 4. From 0 to the number of tables needed. So if you need 1 table, you're going to need 4 chairs. If you need 2 tables, you're going to need 8 chairs. 3, then it's 12. So that's where they get the multiples of 4 from. Now, these are 2 very different situations. If you look, we're going to learn some new vocabulary. The domain of a function is continuous when it includes all real numbers. Continuous means exactly what it sounds like. It means that it's going to go on forever. The graph of the function is going to be a line, which is what we're used to. Remember, I have you guys draw those arrows on the end, or a curve, which is going to be what we're going to concentrate on second semester. Now, more specifically, the domain of a function is discrete when it consists of just whole numbers or integers. The graph of the function is a series of data points. So we've been graphing data points all semester, but it's data points now because we have a situation. So we've been graphing ordered pairs, just going to call them data points. So for example, this graph of you filling up a 10,000 gallon swimming pool, that's continuous because you can have 1.5 hours, you can have 8 hours, it goes on. So the volume of the water in the pool can be determined at any point in time. So if your employer who's making you fill up the pool says, all right, how much have you done in 5 hours? You can say, okay, boss, I've done that amount of gallons because it's continuous. Now, on the flip side of that, think about the restaurant. The restaurant needs to order chairs. Can't order 2, can't order 9, can't order 15. It has to be multiples of 4. So these numbers are going to make a little bit more sense. This is a discrete. It's discrete because specifically one table needs 4 chairs, 2 needs 8, 12, 16, 20, 24, so on and so forth. You can't have one chair. You can't have 0.8 tables. It's not continuous. The ordered pairs that are there are the only ones that work. So that is why we call it a discrete, or the domain is discrete, because it's very specific. And it cannot be decimals or fractions. So once again, domain of a function is continuous when it includes all of the numbers. Like time. Time can be 5.5 hours, 5.25 hours. You can have those numbers. Discrete when it is just whole numbers or integers. In this case, it's whole numbers for the tables. Now think of this problem here. You're going to analyze each situation, identify a reasonable domain and range for each situation. So a bowler pays $2.75 per game. So think about the two things we're talking about. So we're talking about games and we're talking about price. So what kind of numbers make sense for games? What kind of numbers make sense for the price? Can you have negative games? Can you have a half a game? Can you have decimals, fractions? Think about how many games you can play. And then think about the price. The price has to be multiples of $2.75. One game's $2.75, the next one's $5.50, so on and so forth. So the domain is all positive integers because the bowler cannot play for a fractional or a negative number of games. Then think of the range. It's multiples of $2.75. And then a car travels 25 miles using 1 gallon of gas. So the two things we're talking about are miles and gallons. Can you go negative miles? Can you do negative gallons? Can you have 23.9 miles? Can you have half a gallon? These are all things that you need to think of. So once again, The domain is all positive real numbers, since a portion of a gallon of gas can be used. What that means is I can use a quarter of a tank, a half a tank, 0.8 part of a tank, and then the range is all positive real numbers. I can drive 2.8 miles. I can drive 24 3/4 miles. So when we practice reasonable domains and ranges, you want to make sure that you are thinking about all the possibilities that you could have in a situation, and then just write a sentence about it.